Hello students, myself Anna Sahib Gorane from RBNB College Srirampur. Today we see the chapter wave optics, the concept related with the entrance exam, that is CET, JEE, NEET. And in this chapter, firstly we see the interference of light. Firstly, consider the principle of superposition of waves. We know this principle. When two or more waves traveling through the medium arrive at a point of medium simultaneously, each wave produces its own displacement independent of other, and the resultant displacement at that point is vector sum of displacements due to all waves. If the waves are in same phase, if the two waves are in same phase, if waves are in same phase, the displacement adds each other. Displacement add, there is addition of the displacement, adds each other, and when two waves are out of phase, in the superposition, if the waves are out of phase, the displacement cancels each other. When waves are in same phase, as the displacement adds each other, there is enhancement in the displacement. Here there is enhancement, that is increase. Enhancement in the displacement, and here the waves are out of phase, displacement cancels each other. Then as there is an enhancement of displacement, here there is a cancellation of the displacements. Cancellation of displacement. So due to the superposition of waves, there is enhancement or cancellation of displacement depending on whether the waves are in same phase or they are in out of phase. And this phenomenon of cancellation or enhancement of displacement produced due to superposition of waves, we call it as an interference. Phenomenon of enhancement or cancellation of displacement produced due to superposition of waves is interference. Now we see the interference of light. If the two waves are in phase, suppose this is amplitude of wave A, this is also A, these are the two waves, they interfere with each other. Amplitude of this wave is A, amplitude of this second wave is also A. The waves here are in same phase. These waves are in same phase. Here the resultant displacement adds each other, and the resultant wave is like this, having amplitude 2A. Maximum displacement here is 2A. Waves are in same phase. Phase difference between them is 0. Phase difference is 0. Same phase means phase difference is 0. Phase difference is 0. The interference is constructive. Phase difference we denote it by phi. The interference is constructive. There is an enhancement of displacement, and here the resultant amplitude we call it as, suppose R is addition of these two, that is 2A. Resultant amplitude is 2A. If A resultant amplitude is 2A. Or if this is A1, A2, the resultant amplitude will be A1 plus A2. If amplitudes are different, A1, A2, then resultant amplitude here will be A1 plus A2. If the waves are out of phase, see here the figures. If the waves are out of phase, suppose this is the first wave having amplitude A1, second wave having amplitude A2. These are the two waves. These waves are out of phase. Two waves are out of phase. There is a cancellation of displacement and the resultant amplitude R is A1 minus A2. Resultant amplitude is A1 minus A2. If these two amplitudes are equal, then resultant amplitude is, or resultant displacement is 0. Waves are out of phase. If in same phase, we add the amplitudes. If out of phase, there is subtraction of the displacements. Resultant displacement is minimum. Now, if A1, A2 are amplitudes of the two waves in the interference, if A1, A2 are amplitudes of two waves, and phi is phase difference between them. Phi is the phase difference between the waves. If they are in same phase, we add the amplitude. If they are out of phase, we subtract the amplitude or displacement. But if A1, A2 are amplitudes of the two waves and phi is the phase difference between them, then resultant amplitude of these two waves is, suppose R, and that R is given by, R is the resultant amplitude of A1, A2 having the phase difference phi between them. That resultant amplitude is given by square root of A1 square plus A2 square plus 2A1 A2 cos phi. This is the one important formula. Resultant amplitude between them is A1 square plus A2 square plus 2A1 A2 cos phi. If phase difference is 90 degree, if phase difference between them is 90 degree, suppose phi is 90 degree, we know cos 90 is 0, and then the resultant amplitude will be under root of A1 square plus A2 square plus this cos 90 will be 0 and this term will be 0, hence this R will be under root of A1 square plus A2 square. Resultant amplitude will be A1 square plus A2 square. Now, as this R is, resultant amplitude is square root of A1 square plus A2 square plus 2A1 A2 cos phi. Squaring both sides, we write R square is equal to A1 square plus A2 square plus 2A1 A2 cos phi, 2A1 A2 cos phi. Now intensity of wave, we know it is directly proportional to square of the amplitude. This R is our resultant amplitude of A1, A2. Phi is the phase difference between the two waves. Hence, squaring this equation, we get the equation like this. But we know resultant amplitude is directly proportional to A square. Hence, this R square is the resultant amplitude. So, instead of this R square, we write as IR, because I is directly proportional to amplitude square. This is the resultant amplitude, and hence we write IR is equal to A1 square, that is I1, A1 square intensity is I1, plus I2 plus 2, as I is directly proportional to A square, so A is nothing but square root of I, plus 2 square root of I1 into I2 cos phi. In terms of intensity, this amplitude equation becomes IR is equal to I1. IR is nothing but the resultant intensity. I1 plus I2 plus 2 square root of I1 square root I2 cos phi. The intensity is maximum if this cos phi is 1. This is main thing. See, important point. This intensity will be maximum if cos phi is 1. Cos phi is 1, that is, this phi is 0, 2 pi, 4 pi, 6 pi, and so on. For these values, the value of cos phi is 1, and this resultant intensity will be maximum if cos phi is 1, that is the values of phi at 0, 2 pi, 4 pi, 6 pi. We write it as that phi is 2n pi, where n starts from 0, 1, 2 and so on. If n is 0, we get phi as a 0. If n is 1, we get phi as a 2 pi. N is 2, phi as a 4 pi, and so on. Hence, if we apply this condition, we get this IR means maximum intensity, that is I max. Intensity maximum is equal to I1 plus I2 plus 2 square root of I1 into square root of I2, and this cos phi is 1, and this is nothing but I max is equal to square root of I1 plus square root of I2 its square. We get one important equation in terms of intensity, that is I max is equal to square root of I1 plus square root of I2 its square. If these two intensities are equal, that is, if I1 is equal to I2, and suppose we call it as I0. Suppose these two intensities are equal, then this Imax will be square root of I0 plus square root of I0 its square or this Imax is equal to 2 square root of I0 its square, and this Imax is maximum intensity is 4 times I0. maximum intensity is 4 times I0. Very important formula. A1, A2 are the amplitudes of two waves, phi is the phase difference. For maximum intensity, cos phi must be 1, and these are the angles, and we get lastly Imax is equal to 4 I0 if the intensities are equal. Now in terms of amplitude, we write this equation as in terms of amplitude. This equation, this one equation, we write in terms of amplitude. See this equation. Imax is equal to I1 plus I2 plus 2 under root of I1 I2. In terms of amplitude, as intensity is directly proportional to square of amplitude, we write it as A max square. Imax means A max square. Then this I1 means A1 square plus I2 means A2 square plus 2 A1 A2. 2 A1 A2. Therefore, this is nothing but A1 plus A2 its square, maximum amplitude, and we get one important formula: A max is equal to A1 plus A2. Taking the square root on both sides, we get A max is equal to A1 plus A2. Here again, if these two amplitudes are equal, that is, if A1 equal to A2 is equal to A, this A max will be A plus A, that is twice the amplitude. We get A max as twice the amplitude, and such type of interference is a constructive interference. Here there is an enhancement of the displacement or enhancement of the amplitude. It increases. Now from this equation, this intensity will be minimum if this cos phi is minus 1. These formulae are very important. Intensity will be minimum if cos phi is minus 1. Then intensity will be minimum. And value of cos phi will be minus 1 if phi is pi, 3 pi, 5 pi, 7 pi, and so on. The waves are out of phase, the interference will be destructive, and we write this as phi is equal to 2n minus 1 pi, 2n minus 1 pi, where n starts from 1, 2, 3, like this. If we take n as 1, 2 into 1, 2 minus 1, 1 pi, n as 2, 4 minus 1, that is 3 pi, and so on. Then this intensity will be minimum if this cos phi is minus 1. Hence we write this equation like this: resultant intensity will be minimum, and that is equal to I1 plus I2. As this cos phi is minus 1, so this term will become minus, that is minus 2 under root of I1 into under root of I2, and this will be the minimum intensity, and we write it as, very important formula again we get, I minimum is equal to under root I1 minus under root I2 its square, By solving this we get I1 plus I2 minus 2 under root of I1 I2. Again here, if I1 equal to I2 is equal to I0, if we substitute here, we get minimum intensity as 0. I minimum is equal to 0. I minimum will be 0 if I1 equal to I2 equal to I0. Now in terms of amplitude, we write the equation as intensity is minimum. In terms of amplitude, we write this as I minimum as a square minimum. A square minimum is equal to, this I1 is nothing but A1 square plus A2 square minus 2 A1 A2. This is nothing but A1 minus A2 its square, and this is A square minimum. Taking square root on both sides, we get A minimum is equal to A1 minus A2. Again here, if A1 is equal to A2, if these two amplitudes are equal, then we get minimum A minimum is 0. So this is about the maximum amplitude and minimum amplitude, maximum intensity and minimum intensity when the waves interfere, and such interference is a destructive. There is a cancellation of the displacement. These formulas are very important while solving the problem. Now here, as we know maximum intensity, minimum intensity, then we find the ratio of I max to I minimum. These equations are very important. We find I max to I minimum in terms of intensity as well as in terms of amplitude. Ratio of I max to I minimum, that is maximum intensity to minimum intensity. We find the ratio of maximum intensity to minimum intensity. Firstly, we find it in terms of amplitude. In terms of amplitude, maximum to minimum. I max to I minimum, the ratio is A1 plus A2 its square divided by A1 minus A2 its square. The ratio of maximum intensity to minimum intensity in terms of the amplitude is, the formula is like this: I max to I minimum is A1 plus A2 square divided by A1 minus A2 square. If A1 is equal to A2, and suppose that is equal to A, if these amplitudes are equal, then the ratio A1 upon A2 is 1. If amplitudes are here equal, we take the ratio of I max to I minimum in terms of the amplitude. This is the formula. Here also, if amplitudes are equal, then A1 upon A2 is 1. But this I max to I minimum, A plus A to A minus A, 0. As this denominator is 0, this ratio I max to I minimum is infinity. As denominator is 0, the ratio of maximum intensity to minimum intensity is infinity. Now secondly, we find the ratio of Imax to I minimum in terms of intensity. Second point, the ratio of Imax to I minimum in terms of intensity. These all formulae are very important in terms of intensity. In terms of intensity, I max to I minimum ratio is that is equal to square root of I1 plus square root of I2 its square divided by square root of I1 minus square root of I2 and this bracket square. Again, if the intensities are equal, if I1 equal to I2 is equal to I0 or I, what will happen? The ratio of individual intensities will be 1. That I1 upon I2 will be 1. But I max to I minimum I1 plus I2, that is I0 plus I0 square root of 2 I0. But this 2 square root I0 minus square root of I0, this becomes 0, and as denominator is 0, again here the ratio I max to I minimum is infinity. This ratio will be infinity. Now next part we see the ratio of individual intensities.